Hello guys and welcome back to this tutorial. In the previous video, we went over how to make these walls and prevent the ball from going through them. In this video, we're going to make the blocks break. So let's get into it. First of all, we need to create a script for that. So let's go to our scripts folder and create a new C# script. Call it block and let's open it. So let's open it here in the scripts folder. And there it is. As always, we have the start and update method. Just a reminder, start executes once the object is first started, and the update method executes every frame. For this, we're going to need two sprites to change the look of the block. So they'll be private, and we need to serialize them to set them in the inspector. So serialize field private sprite. We'll call this destroyed 1 and another one destroyed 2. Also we need a reference to the sprite renderer. So private sprite renderer, and we will call this sprite renderer. We will assign the reference in the start method. So sprite renderer equals, and in order to get a component, we need get component method, and we will pass the type of the component here. So sprite renderer. Next, we need to detect collision between the block and the ball. We won't be needing this update method. Instead, we will need an onCollision enter 2D. So onCollision enter 2D, and it takes a collision 2D parameter that holds the data for the collision. So let's check if the other object we collided with is the ball. If call dot game object dot compare tag, and here we put the tag for the ball. Let's call it ball, and we will assign this tag later in the inspector. So if we have collided with a ball, we will start a coroutine. A coroutine is like a thread, you can think of it like that, but executes in its own timeline. So it won't block the program, and you can tinker with time in it. So private, and every coroutine has to return an I enumerator, and we will call it destroy block. It takes no parameters, and it will change the sprite of the block. So sprite renderer dot sprite equals destroyed 1. Then we will wait for a set amount of seconds. So yield return new wait for seconds, and let's say about 0.1 seconds will be fine. And we will do the same thing and replace the texture with another one. So sprite 2 here, and we will wait for another 0.1 second. Then we will destroy the game object. So destroy game object. And be careful, don't use destroy this here, because this will reference only the block script, but we want to destroy the whole game object. And in order to start the coroutine, it's pretty simple. Just start coroutine and call it by its name. So destroy block. Also, if I do that during these two times, the 0.2 seconds here, the collision will be calculated too. So we don't want that. Whenever we first collide with it before changing the sprite, we just disable the collision, and that's pretty simple. Just destroy the collision component. So destroy get component and box collider 2D. That's it. Now, if we go back to the Unity editor, don't forget to select the ball and assign the tag for it. So let's add tag here. Click on this plus icon and call this ball. Select the ball and add the tag. Also, don't forget to do that to the prefab here. Select it and add the tag ball. Next, select the block prefab and add the block script that we have just written, and we will assign these two textures. Let's go to our sprites folder, and I have prepared them, so let's import them, and I will link them in the description. So let's drag these two here, and for these I won't do the same thing that I've done for the others. I want the filter here to be bilinear because I want to give the block a little splashy effect. So now let's select the prefab, go to the block script here, and we will assign these two sprites. The first one will be this one, and the second will be this one. Next, let's try the game. Hit space, and they are a little bit small, yeah. Let's fix that, and it's pretty simple. In the sprites, set the pixels per unit to 32. Hit apply, and let's run the game again. Hit space, and that's it. Looks good. Now, you see that if before I launch the ball, I go to the right or to the left, the ball is hanging in the air, and that's not supposed to happen, so let's fix that now. And we will do that in the manager script. So let's go to our scripts folder and select the manager script. Now we will do that in the fixed update because it includes movement. So fixed update, and we will check if it's the start. So if it's start, we're going to calculate the same distance and half the width here. Let's copy and paste them. And if the distance, so absolute value, mathf dot absolute value of the distance is greater than half the width. In that case, we need a vector 3 to hold the ball's current position, and it will take ball dot transform dot position, and another one to calculate the new position. So vector 3 new position, and it will depend whether the distance is positive or negative. So if it is positive, this is a conditional operator that will take one of two values. So if it is true, it will take this value, so a new vector 3, and it will have on the x-axis the player transform dot position dot x plus half the width, so it will be on the extremity of it minus an offset that we will set in a bit, so it won't be hanging right on the edge. And for the y value, it will be the same, so the position that we have just calculated dot y, and for the z it will be 0. Sorry for that, just offset here. We will create this variable in a bit, else if it is negative, we will take this same thing here, copy and paste it. This will be minus, so it will be on the other side, and plus an offset, so it won't be hanging on the edge. And then we will set this position to the ball, so ball.transform.position equals this new position. Now let's create these offset variables. So let's go up here, and they will be serialized. So serialize field private offset. Private float offset, yeah. Let's go back to the editor. Wait for it to compile. Select the manager. and we'll give the offset a value of, let's say, 0.5 for now. Let's try the game. And you see that we have a little problem here. That's because we are directly resetting the value, and this will be fixed simply. Let's go back here. And it is first because we have to do this for the distance. And we won't be setting the position directly here. We will lerp it instead. So vector3 dot lerp between two values. The first value will be the initial position of the ball, and the second value will be the new position. And we will lerp with time dot delta time multiplied by an offset speed. So what does this mean? A lerp is a linear interpolation between two values, and we will give it a third parameter. So this is pretty simple to explain. Let's draw it a little. Let's draw it quickly. So if I have a point here, A, and another one here, B, if I want to lerp C between them, we will give always a third value, which is the one that's here. If this value is 0.5, then C will be the middle between these 2 points. If this value equals 0, C will be equal to A, and if it's 1, C will be equal to B. Same if it is any value in this interval between 0 and 1, it will pick a position here. That's pretty simple. And why do we need a time dot delta time? It's to make it frame independent. So this here is the time elapsed since the last frame. Let's create the variable here, so private float and offset speed. And yeah, this is serialized here, so we won't be putting that hyphen there. And same here and here, just naming conventions, nothing too important. Now let's go back to the editor, wait for it to compile, set this to 0.5 and this to something like, let's say 15, and run the game. Now you see it's working. The ball actually is hanging too far from the player, so let's increase the offset. Just pick something that you like, something like that feels good. Now let's launch the game, launch the ball, and you see it's working pretty good. So this is enough for this video. I hope that you like it. If you have any questions, ask them in the comments. And don't forget to hit the subscribe button if you like this. And see you next time.